All right, so now on to note card 260, where we're going to do an example of theoretical and experimental, and I'm going to have you write it down. So this example shows the results of rolling a standard die 50 times. So the first result, the result of getting a 1, so the 1 is up, that happened 4 times. The frequency is how many times it happened. Getting the 2 up, that happened 10 times. The 3 up, that was 9 times. The 4 up, 5 times, 5, 12, 6, 10. Okay, so this is an experimental, okay? This is experimental because somebody rolled it 50 times. So this is experiment. Now over here in part A, it says, what is the theoretical probability of rolling a 4? Well, there's 6 faces. There's 6 sides. So in theory of rolling the 4, it would be 1/6 because you roll it and there's an equal chance of getting the 4 up. Okay, so that's 1/6 of a chance. But over here, based on this experimental probability, what was the experimental probability of rolling a 4? So we look, they got a 4 5 times out of 50 trials. So it was 5 out of 50, which reduces to 1/10. So what are those as decimals? Well, 1/10 is smaller than 1/6. 1/6 as a decimal is 0.1666666, and 1/10 as a decimal is 0.1. So this is actually lower. The experimental probability is lower than the I'm sorry. The experimental probability. I'm getting a phone call. Hold on. The experimental probability is actually lower than the theoretical probability. Sorry, I was kind of a hot mess with that because I was getting a phone call. These braids going on. Anyway, so yeah. Okay. All right. Okay. What could get this experimental probability closer to the theoretical probability? We just talked about it in the last video. Have more trials. Now, I know we had 50 trials here, but the more trials you have, the closer your experimental gets to your theoretical. So go ahead and pause me and finish up note card 260. All right, so here is note card 261. Let me actually move this up. All right. Now, note card 261, just another example. Here's a spinner. It has some letters on it, and they did an experiment, and they actually spun the spinner 75 times. And so here's how many times they got each of the letters. So if you look, they got more F's than anything. The second one was B's, and then E's, and then C's, and so on, okay? So this was an experiment. Now, let's take that away and let's think, what is the theoretical probability of spinning a shaded letter? Now, you might not be able to tell, but A, B, C, E, F, and G are all shaded. H and D are not. So how many are shaded? There's 6 of them. How many total letters are there? There are 8. So 6 out of 8 is that probability, which is 3/4. Okay, so that's 75%. All right. So that's the probability in theory of spinning a shaded letter. Now, if I look at this experimental information, what is the experimental probability of spinning a shaded letter? Well, let's see. Which ones were shaded? A, B, C, and E, F, and G. So A, B, C, I add those up. E, F, and G, I add those up. So if I add all of those up, there are 60 of them. Let's see. 17, 27, 38, 61. No. 17, 27, then go to E. That would be 38, 51. Yeah, there's 60 out of the total 75 trials, okay, which is 4/5. Now remember, this was 0.75. 4/5 is 0.8. So let's compare. This is higher than expected. We would in theory expect it to be 75% of the time, but it actually was 80% of the time. So that happens too. It can be lower than expected or higher than expected, but to get it closer, you have more trials. Okay, we would have more spins here. So go ahead and pause me and finish up note card 261.